Working. Oh, oh, oh. हरिः ॐ शन्नो मित्रः शं वरुणः शन्नो भवद्वर्यमा शन्न इन्द्रो बृहस्पतिः शन्नो विष्णुरुरुक्रमः नमो ब्रह्मणे नमस्ते वायो त्वमेव प्रत्यक्षं ब्रह्मासि त्वमेव प्रत्यक्षं ब्रह्म वदिष्यामि ऋतं वदिष्यामि सत्यं वदिष्यामि ॐ सहना भवतु सहनो भुनक्तु सह वीर्यं करवावहे तेजस्विनावधीतमस्तु मा विद्विषावहे ॐ शान्ति शान्ति शान्तिः
Namaskar and good afternoon to everyone. I would like to welcome you all to today's Vimarsh talk by Professor Raju, Professor C.K. Raju, on an unusual but interesting topic, and that is practical Ganita versus religious mathematics. As we go along, I hope to discover more about the nature of the subject. It is not very often that we hold an event on mathematics. Of course, we talk about China, Japan, Indo-Pacific, and many civilizational topics also, problems of governance and so on. But mathematics we have not touched so far, except that we had a Vedic mathematics roundtable in which I met you the first time. And I'm very happy that Professor Raju has accepted our invitation to talk on this subject today. I'd like to just give a brief introduction of our esteemed speaker. Professor Raju is PhD from the Indian Statistical Institute, Kolkata, and was the member of the CDAC team, which built the first Indian supercomputer, Param. I think it was in the 80s, 88 to 91. I remember it made a big news at that point of time, and we were under sanctions. And I think it was also, I think it was probably one of those Pragyan moments, if I'm not mistaken. It was a big achievement for all of us, and we're still proud of that. So he was part of that team and made a contribution to the development of that. Professor Raju has taught mathematics, done a lot of research, published several papers on the subject. And these books include, and these are very unusual and very interesting topics. So I'll read out from his CV some of the books that he has written. Ending Academic Imperialism, which was published in 2011. Euclid and Jesus, 2012. Cultural Foundation of Mathematics, 2007. Towards a consistent theory, which was earlier, 1994. 11 Pictures of Time, 2003. So these are the subjects I think which relate to physics, mathematics, philosophy, science. So all this is represented this in his work. In his work, he has shown how to relate science and religion, which I think is a very, very interesting facet of Indian thinking. Because for us, science and religion are not two different things, and I think all this talk about secularism, which has unfortunately done a lot of damage. So for us, it was just thinking. And he has proposed and given a new philosophy of maths called zeroism. I hope he will explain that. He has received several honors and awards, including the TGA award in Hungary in 2010 for correcting Einstein's mistake. Now, I'm a student of physics, so would very much like to understand what mistake of Einstein that he corrected, because for us, Einstein is infallible. So, yeah. So that's something which he did, and he's received also several other awards, but one I picked up from his vast CV is Bharatiya Dharohar Award MP. So, which relates to the Dharohar, Indian heritage. So that's something that he received. And you can see from his works and from his CV that Professor Raju is an original thinker and has made a significant contribution in the field of mathematics, physics, and Indian scientific heritage. And he was also associated with certain publications on Indian scientific traditions and written certain books and contributed articles to that. And he, even today, is a number of his talks and articles are available on the internet, in YouTube, on YouTube. Why did I say YouTube? Slip of tongue, I suppose, but Freudian slip. I think we should be having a YouTube. Okay, so so I was reading one of your articles, or rather a summary of it, which you was there in your link, and with your talk at the IIT Kanpur. You were telling them, and it was very interesting when he points out that the West, actually, in all his work, I think what he's exposing is West's illiteracy on mathematics. Now, it may come as a big surprise, and how it compares with the Indian knowledge, and even including Egyptian also at some place. So he says that the West was much behind Indian and Egyptian knowledge of mathematics, much behind. And they copied a lot of this knowledge. And when they copied it, they did not understand it. So they had huge difficulty in understanding Indian. So that's all right. I think even today, West doesn't understand Indian mind. So because we are quite complex and our thinking is very different, but in the field of mathematics. And then he goes on to say, and I'm sure he'll expound on this during his talk, particularly in the context of calculus, that since they didn't understand the Indian calculus invented by Aryabhatta way back in the 5th century, so they didn't understand it, so they invented their own calculus, which is basically the formal math. And he talks about real numbers. He says there's no need to invent real numbers and use real numbers to use them in calculus. They didn't understand it. So there is an alternative way of understanding and doing calculus. And that is what Bharatiya Gan ita is all about. I hope I have understood. Okay. So Bharatiya Ganit is easy to understand, easy to apply, and has far greater applications than you will ever find in a very formal expounding of calculus as in the West. So that's, I think, the sum and substance of that article which I read, and it was a very interesting article. And this topic, practical Ganita versus religious mathematics, I suppose some of this will feature in. But we're very happy that he's talking to us. It is essentially a non-technical organization, but I see some very senior former uh, 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 defense officers here. Gormade is here, he was in the Navy, and I can see some others. Professor Agarwal is also here, also. So, but it's essentially non-technical audience, so that is something that you probably will hopefully understand at the end of the day. What is this practical, the Bharatiya Ganita, which is so practical? And I also must thank you for disabusing me of that concept of Vedic mathematics, which you very clearly said. I always thought Vedic mathematics means mathematics in Vedas, but he very clearly said that there is nothing in Vedas about Vedic mathematics, and we should be careful in using the term Vedic mathematics. So it's a great mathematics, great sutras invented by the Shankaracharya. It's really fun doing that. But using the word Vedic is maybe a somewhat of an issue. So with those words, I want to welcome you, sir, for accepting our invitation, and the floor is yours.
So I'll speak from here. Thank you very much for inviting me and for giving me this opportunity to discuss this issue publicly, because people hear the topic itself and they shut their minds. What is this nonsense? No, I mean, this is how people react. And I think, therefore, I've been trying for the last 10 years to have a public discussion on it, which has proved to be extremely, extremely difficult. So let's start with this. The first point I want to make, well, this is the summary. I was doing a book on Ganit versus mathematics in the Shimla Institute of Advanced Study. And this is its summary, that Ganit is different from math. We translate it, it's a wrong way of to translate. It makes math easy and it makes science better, because we are not just talking about how great we were, we are talking about how great we can be. Right? We are talking about the future, not just about the past. So the key differences are that, of course, I'll be talking about that Ganit is practical and mathematics is religious, hence unfit to be taught as a compulsory subject in schools. I think you mentioned secularism and so on. Now, religious propaganda should not be taught as a compulsory subject in schools, or anything which contains religious propaganda should not be taught as a compulsory subject in schools. So I think that is a problem with mathematics which we don't understand. Now, of course, many people are worried, what is this nonsense you're talking about? Where is the religion in 1 + 1 = 2? That's the standard question which I have been facing for the last 10, 15 years everywhere. In Iran, in South Africa, wherever you go, this is the standard question that is asked. Where is the religion in 1 + 1 = 2? And the point is that people are thinking of the KG method of doing 1 + 1 = 2. Like this. This is how you do it in KG, right? And there's nothing religious in this. So this is an empirical method. I'm seeing those oranges. I'm seeing that one orange and one orange make 2 oranges. It's an empirical thing. And an empirical thing is not going to be religious. Nothing religious in that. But this is not the way 1 + 1 = 2 is done in mathematics. Unfortunately, most people don't know. So I'll come to that. First of all, 1 + 1 = 2 like this is the Ganit method. Why? Because the empirical or Pratyaksh Praman is accepted by all schools of Indian thought. And it is the first means of proof, and it is the only means of proof which is accepted by all Indian schools of thought, whether it is Nyaya, whether it is Sankhya, whether it is Vedanta, whether anything, Buddhism or even Lokayat. Everybody accepts it. So it is stated in the Nyaya Sutra 2. I can just quote it for you. These are the 4 means of proof: Pratyaksh, Anuman, Upman, Shabda. These are 4 means of proof, Nyaya Sutra. And they are elucidated here in this. This is, now does this work? Yes, it does. Okay, so this is Pratyaksh. So an example is in Aryabhat Ganit 13. I won't give you all the details because I may run short of time otherwise. But anybody wants, those links are there. These are all files which are publicly available. So he would say that, how do you decide the vertical? You decide it by means of a plumb line. How do you decide horizontal? You decide it by the surface of water. This is an empirical proof. This is what your mystery also does. And same way you have Anuman. So Anuman is inference. You infer. How do you infer that the earth is round? So Aryabhat inferred that the earth is round. The very word for it is Bhugol. So it is round because, as Lalla will explain, far off trees cannot be seen. So it is anuman, it is reasoning, but it is reasoning based on facts, reasoning based on observation. And by this means, you can actually also calculate the exact radius of the Earth. It's explained in my books and so on. Very easy. And all Indian texts will have an estimate of the size of the Earth in Yojan. So I won't go into the other things. Upman, for example, Aryabhatta will say it's round like a kadam flower. And I won't go into Shabda, which is used sometimes. So let's skip that. The point is that this Ganit method is practical. It is nothing religious about it. Okay, so the KG method is not allowed in mathematics. And this is a point which you need to know because people just identify it. The first thing you learned, that is what you learned in KG, and so you are stuck on it. But it's simply not true. You cannot use that method in mathematics. Let me explain why. Empirical proofs are prohibited in mathematics. They are prohibited, and nobody tells you this properly. They tell you, but they tell it to you in such a way in the school text that nobody will ever retain it. It is stated in the school text, but very, I'll show it to you just now. So the point is, it is prohibited in present day math, which is also called formal math or axiomatic math, or the term I prefer is Western ethno-mathematics. That's the term I like. So empirical proofs are not allowed. So this KG method is not allowed. So what is to be done? So how do we know this, first of all? How do we know that it's not allowed? So you have to just pick up any text on mathematical logic, which will define a proof. So here is a text by Mendelssohn on mathematical logic. So this is the definition. So a proof is a sequence of statements in which each statement is either an axiom or is derived from preceding axioms of preceding statements by means of some rule of inference, rule of reasoning. So I put it here. This is the paraphrase. It's a sequence of statements. So it must be, each statement must be either an axiom or must be derived from preceding statements by means of some rule of reasoning. I cannot say I see it, therefore it is true. That cannot be part of a proof. What is the rule of reasoning? Simple thing, say A implies B, A therefore B. All right, I hope this point is clear that empirical is not allowed in mathematical proof. And this is also stated in our class 9 NCERT text. It's compulsory reading for all, but nobody reads it. So how? On page 301, it states, I just look at the last line, beware of being deceived by what you see. Okay, so a proof must be established using only logic. You cannot use the empirical. This is stated in the text. Nobody reads it. Nobody understands it. It's not drilled in. But this is the fact that in mathematics, formal mathematics, axiomatic mathematics, Western ethno-mathematics, empirical is prohibited. All right. And I have the text here. If you like, you can check it or you can check it. This text is available online, page 301. Okay. So you are not allowed to, math allows only anuman, not pratyaksha. Let me put it in Indian terms. And of course, this text is compulsory reading for everybody. If you did not read it, I think it is your problem actually. You should have read it, but we have to wonder about how we were so indoctrinated that we came to believe something, although it is stated in the text, but it's not known to people. Something amazing. I find it personally very amazing. It's not hidden. It is there open, but you don't know it. All right. So this is my first proposition. That's the first part of the proposition, that Ganit is different from math. Ganit accepts empirical, math rejects empirical. Very clearly rejects it. No part of mathematics, as currently taught in our schools, in universities, and everywhere. Well, AD we make an exception. So one consequence of prohibiting the empirical is that 1 + 1 = 2 becomes extremely, extremely difficult. How will you prove it without appealing to the empirical? Just think of it. You can't bring in the empirical at any point. So Here is the proof given by Bertrand Russell, who took 378 pages in his Principia. And here is the proof. And do you even understand a single sentence on that? Complete gibberish. He got the Nobel Prize. He's supposed to be such a towering Western intellectual. Why does he need 378 pages to prove 1 + 1 = 2? Because the empirical is prohibited. You have made it extraordinarily difficult. You have made math extraordinarily difficult without understanding why. Okay, so let me go back to this. The point is, you made it so difficult. What did it do? Did it help us in some way? Does it help us in the grocery shop? Well, I don't think that deserves a very serious answer, so I've drawn a cartoon. Here is Russell in a grocery shop, and he is trying to calculate how much of a dozen of something will cost. And he's not able to do it because it takes 378 pages just to do 1 + 1 = 2. How long will it take to calculate 74 into 12? So this does not give you any practical value anyway. If you go in a grocery shop, you have to see the articles they are talking about. You have to do it empirically. You can't do it axiomatically. So that's the thing, the point, that it is extraordinarily difficult, but it is extraordinarily difficult without adding an iota of practical value. Okay, so Ganit makes math easy. That part you've seen. 1 + 1 = 2. The KG proof is very easy because you do it empirically. And the mathematical proof is extraordinarily difficult because you do it axiomatically. All right? But that's not the end of the story, of course. So in axiomatic mathematics, there isn't even a unique concept of the number 1. You think they have reached the limit of difficulty? It is not. Because there is a distinction between the natural number 1 or the cardinal number 1 with which Russell is dealing and the real number 1. Now, real numbers are also done in class 9, the first chapter, class 9 math text, but nobody reads it and nobody understands it. All right. And the point is that real numbers require a different set of axioms. For natural numbers, you can use what are called Peano's axioms. For real numbers, that will not work. You have to use set theory. And axiomatic set theory is something most professional mathematicians don't understand. Almost nobody, if you set them up and ask them, they won't even be able to define a set, most of them. So it is different from naive set theory. You see, what is naive set theory? You say, okay, what is, you teach it in school, you say set is a collection of objects. Complete nonsense. So you cannot define it like that. And I do ask this in my pre-test. So you try to define sets. They're taught at an early stage. So you're taught in class 10. And if you define a set as a collection of objects, you can't do it because what is collection, what is object? And then the point is that you run into Russell's paradox. That's the point here. You take the set of all those sets which do not belong to themselves. And now what happens? Does this set belong to itself? If so, by its definition, it cannot belong to itself. And if it does not, then by its definition, it must belong to itself. So that is Russell's paradox. So if you define a set so loosely as a collection of objects, you run into this. So naive set theory does not work. That is why axiomatic set theory was invented in the 20th century, in the 1930s. All right. So let us leave that. You can't define it like that. That naive definition does not work. And the point is that you have a set for which R belongs to R is both true and false. Now, if you have a statement which is both true and false, if you have a statement of the form A and not A, then you can infer any B from it. Any nonsense proposition B from it can be inferred. So the whole theory fits. If you have a proposition which is true and false, then any nonsense can be inferred. So the entire thing, the entire theory collapses. Because A and not A implies B is a tautology. For any statement B, whatever nonsense, rabbits have 2 horns, for example, it's implied. So you can't have a contradiction in a mathematical theory. It's a drastic thing. It completely destroys the theory. Therefore, you can't have Russell's paradox. Therefore, you can't work with such naive definitions. But we don't care. We say you students don't learn for knowledge. They go for exam. It's stated in the text. Repeat it. That's what they think. So this is what they do. But it is not on. You can't really do it like that. It's not correct, as you just saw. Okay, so it's deliberate. The aim of colonial education to keep you ignorant is a deliberate thing, and I'll come back to that. So they repeated, but never mind. In JNU, I offered a prize of 10 lakh rupees to prove 1 plus 1 equal to 2. It is there on video in front of the VC, who is now the chairman of the UGC. He was sitting there, it has been offered, and nobody accepted it. Just think, of a leading university, I am offering a prize of 10 lakh to 1 plus 1 equal to 2 in real numbers. Nobody accepts it. It is there. There's a video there, so you can see this video. Now, I won't go into it. It's there online, and it's on statistics for social sciences. And there I asked this question. So you can take a look. It's on YouTube, whatever you call it. It is there. And this is my Cape Town challenge that you prove. I first gave it in Cape Town. You prove 1 plus 1 equal to 2 without, in the manner of Russell, without assuming any theorem of axiomatic set theory directly from the axioms. So you can't avoid axiomatic set theory. You have to use the axioms, you have to know the axioms, and you have to be able to understand the implications, which people don't know, as I said. Even professional mathematicians don't know. They set it aside. How this is happening, why this happens is a different story. Okay, so you want to prove it in that fashion. And this is not, and I also gave a second prize. If you don't have time, do it in 1 week. I'll reduce the price to 1 lakh. Nobody accepted it. So you think of a state of affairs, what we are doing in this country. In the greatest, in the best university, you have got 1 plus 1 equal to 2 to challenge. Nobody is willing to accept, and nobody is ashamed. Nobody is resigned. You're teaching, if a professor of mathematics education, if you don't know, then you should do something about it. No? We are not disturbed. Now, I think this is a civilizational challenge. It's a major civilizational challenge that we are stuck into it. It starts from Macaulay's statement that the West is immeasurably superior in science, and this is the stuff that they give us. I'll come back to that. Okay, so the point is, why am I talking of real numbers? Because real numbers are supposedly needed for calculus. Take any book on calculus. Say you need real numbers. That's why they are taught in our school text in 9th standard. They don't understand what real numbers are. But calculus is needed for all science. So I'm not just talking about something in the air. You want to do science, you want to write down the equations, the differential equations of physics, you need to have real numbers for that, at least according to current mathematics. So you must know real numbers. So they are taught in class 9, 10, they are taught to indoctrinate. So you feel comfortable with real numbers, you heard of them, you don't know what a real number is. Okay, the professors don't, these children know. But they get indoctrinated. And they start thinking, yes, that is there, it's real. The word is also real number, it's not real at all. So anyway, the point is that because of this, mathematics is so difficult that California, which is the US technology hub, has cancelled teaching of calculus in schools. The idea that you teach data science, but that's wrong, because if you try to teach data science needs statistics. You want to do some AI programming, you have to have statistics. It's all probabilistic. You know, ChatGPT even does arithmetic at the moment probabilistically. So it gets all the answers wrong if you do some little complicated arithmetic. So the point is, if you have AI programs like this, they will have bugs in them without a proper understanding of probability and statistics. And for that, you also need to know calculus. And the point is that this will be the decision makers of the future. And somebody makes a program, you don't know what is in the program. There may be thousands of lines of code. You just follow it, it is there. And the machine says so, and that is true. So we need to make calculus easy so that people understand things, so that you don't make such mistakes, so that you understand statistics and so on. That's the point. I made the point to Google also, but anyway. So I'm saying this can be done calculus can be made easy if you teach it as Ganit, the way it originated in India with the 5th century Aryabhata. And as the numerical solution of differential equations. That is what he did. He used a technique which is today called Euler's method, wrongly called Euler's method. Euler, of course, knew about Indian texts, and he copied and he named it after himself. So we'll come back to that. So Ganit makes calculus easy. Since this is a non-technical talk, I won't get into technicality. Let me give you all the other details. This has been demonstrated. How it has been demonstrated in teaching experiments which have been conducted for the last 14 years in 3 countries, in 5 universities with 8 groups. So Central University of Tibetan Studies in Sarnath, for example, this is a course on calculus without limits. That is SAM 10. And there were 4 groups in University Science Malaysia. These are the technical reports. I'll just give you the news report. So you can do calculus, make it easy. And this is something which did excite people, which did excite the students, but there is a lot of resistance from the mathematicians. They will lose their jobs. It's a simple thing. They don't even want to discuss. Okay. So, well, it was done also in Ambedkar University, Delhi. So there is Shyam Menon, who was the Vice Chancellor. And so on. It was done in Tehran. And it was done in SGT University, Delhi, science and engineering students, and so on. So this has been demonstrated. And now I gave a talk in IIT Kanpur, you mentioned. This is the abstract of the talk, or this is the whole talk itself. It's the presentation for the talk. You can take a look at it. So you can see the abstract. The point is, the hope, plan to start teaching this calculus in IIT Kanpur from February, because see, December it's very cold. I find it difficult to go there. My blood pressure goes up that much of cold. So important point is, not only does it become easy, it enables students to solve harder problems which are not covered in usual calculus courses. So here's an example. Now this is an example done by, well, here is a tutorial. So I'm giving an example. I don't know. Now maybe I should skip this. If you say it should. These are what are called Jacobian elliptic functions. They are non-elementary functions. And why are they needed? They are needed for the simple pendulum, which is the first science experiment that is performed in schools. So you need it for the correct theory of the simple pendulum. I'll give you that reference. So these are the Jacobian elliptic functions. And you cannot do them with the normal calculus course. So they give the wrong theory. The simple pendulum, the first science experiment, they give you the wrong theory. It's contrary to what you observe. And science is basically about observations. Your theory must agree with observations. If not, you throw out your theory. So I'll give you the experiment on that. But the idea is you can do harder problems which are not covered, because the general idea is calculus only covers what are called elementary functions. Jacobian elliptic functions are non-elementary functions, so they are not covered in elementary calculus courses. They are covered subsequently, but not in college calculus courses, not in school calculus courses. Okay. And for the simple pendulum, if you want the experiments and so on, my son performed them. And he wrote this report, which is available publicly, that the time period of the simple pendulum, I'll just give it to you very briefly. The usual formula is T equal to 2 pi root over L by G. So the time period is independent of the amplitude. If I keep the pendulum here or here, it will have the same time period. This is completely wrong. You can observe that it is wrong by performing an experiment, in which he did perform and observe. The point is the theory is complicated. So the experiments are done here. They are reported here at the end. This is a school project at class. So these are the experiments. So the time period measured. It's very simple for experiment to perform. The first experiment you perform, measure it, and you find that the theory doesn't agree with the observation. So why do you teach that theory? Whole idea of science is that you should fit the observation. So this is available online. The link is there. you can take it. I will put up the whole thing. So the point is that at least calculus taught as Ganit leads to better science teaching. Actually, it leads to better science. But to explain that, I cannot avoid technicalities. Okay, this is something technical because you can't just say do science in very simple terms. So I'm just giving you a very simple example of a simple pendulum, which is an experiment which is done in schools, which anybody can perform and check that the theory doesn't agree with the observation. And so you have to revise the theory. But to revise that, you have to teach calculus differently. That's the point. And you can do that the Ganit method. That's that. So in general, if you do calculus as Ganit, there is no loss of practical value because real numbers are never used in practice. They are imaginary things, they are metaphysical things, they have no real existence. Just the terminology is misleading. Okay. Well, let us simple example is how do you, if I want to say we sent a rocket to the moon, how do we calculate its trajectory? You do it on a computer. Or you do it by hand, it doesn't matter. But these days you do it on a computer. Computer cannot represent a real number. You want to write a program for Chat GPT or whatever, you are going to use statistics. You are not going to use real numbers because you will use a computer. A computer program cannot manage real numbers. It uses what are called floating point numbers because it has finite memory. A real number requires infinite memory. I'll come back to that. So the point is that for all these problems, you have to numerically solve a differential equation the way Aryabhat did. And this was my experience in CDAT. We're talking about space, we are talking about oil, whatever we're talking about scientific applications, all the time that's what you're doing. So the point is computers can't use real numbers. Our text teach that calculus has to be done with real numbers. All applications are done on computers and computers can't use real numbers. Very simple thing. Now here is this is a classroom thing. If you want to see, these are my classroom notes from long ago, 20 years ago, and see, this is what a floating point number is. It's a long thing with C program. So I'll just leave it to you. The point is the computer has a finite memory. It cannot represent an infinite decimal expansion. It can only represent finite now. So it will use, say, number has to be represented. It will use 32 bits or 64 bits, depending on what kind of system you have. When those notes were written, it was used to be 32 bits. Now it is, of course, standard is 62 bits. And this is also explained long ago in a 20-year-old paper from Hawaii. So you do not even have the associative law. The axioms for real numbers, associative law for addition does not hold for floating point numbers. You understand associative law? A plus B plus C is equal to A plus B plus C. That's not true for floating point numbers. Why not? Because if I add a big number to a small number, the small number disappears. So if I take -1 plus 1, that is 0, add it to a small number epsilon, that will give me epsilon. But if I take 1 plus epsilon, that epsilon will vanish. So -1 plus 1 will give me 0. That's why it fails. So the point is, this does not apply, it does not work with computer, is not needed in practical applications, never used in fact, cannot be used. All right. And all programs, including all programs on statistics or whatever you have. So this is my point summary to begin with, that you are able to do harder problems not covered in stock calculus courses. There is no loss of practical value because you will never use real numbers, but it is extremely difficult, extraordinarily difficult. You offer a price of 10 lakh rupees, nobody is able to prove even 1 plus 1 equal to 2 in real numbers. That's the state of affairs. Now you imagine how we reach such a state of affairs. How did we fall to such depths? I think we need to understand that because that is a very, very major problem. Okay, so the great colonial superstition is that it's a superstitious fear. Why you're not going to ape the West? You're going to do something different. They are terrified of the thought. Must ape the West, and if you don't ape the West, they're terrified that you're doing something funny, something will happen, something will fail, there'll be some catastrophe. That's a superstition. Right? And this is the key superstition instilled by colonial church education. It was church education. Let's be very clear about it. So ape the West or risk a catastrophe. And simple trick is, why should you ape the West? Because they'll say West is superior, so therefore you ape it to become superior yourself. And they've been saying it for so many years, 200 years, we are observing, we are aping, we are not getting any better. So I think there is a major problem, we need to think about it. So let's take a concrete example. Class 9 school math text, chapter 5. I am sticking to only class 9. I am not going beyond that. A lot of advanced things that you can do, but let us just do the first stuff that is there in class 9, because class 9 math is compulsory for all. So it says that this is class, okay, this is just the introduction to Euclid's geometry. This is what it is. It says that the Greeks did a superior math. Now, this is the thing I want to show you. They did something superior compared to all others, compared to Indians, compared to Maya, compared to Egyptians, compared to Babylonians, and so on. They did geometry for some practical purposes. We want to do it for practical purposes. What's wrong? So the Greeks were interested in the reasoning why certain things work. It's the statement that is making it. It's completely false. But we'll come back to that. Okay. So Greeks were interested in reasoning and deductive reasoning. So that is the story that we are told. That is the story our children are told, and they have been told for the last God knows how many years. So first thing I asked NCRT, what is the evidence for Euclid? So I got 3 answers. 2007, Hukum Singh was the head of the math department, came for my book release in India International Center. He simply said, why do you want evidence? We go by a committee. He actually said it. So I had no response. I did not know what to say. So I got a cartoon made. So that is what I can say. There is nothing I know. If somebody talks like that, who is the head of your educational system, what can you say? So why do you need evidence? We go by a committee. So why do you want evidence for Euclid? Then somebody said, okay, don't give them up, make an official complaint. So I made an official grievance. What is the primary evidence for Euclid? So I asked for what is the primary evidence for Euclid. They said they gave references to 3 Western texts in which Euclid is mentioned. This was in 2019. So I said that we are talking about history. We want to have primary evidence. I want to know what is your primary source. I want to know whether there is any primary source. And so what did he say? They increased the number of tertiary texts from 3 to 6. This is the level of seriousness that we have. Now, what do you do when you are faced with this kind of a stone wall? And nobody objects. You find a lot of stuff about Pythagorean theorem, this and that, but and this is there online. Their response is there online. It's on my blog. It's an official letter. Sorry, it is taking a lot of time. This is slow internet connection. So this is there on my blog, and all the details are there. So you can just check it. I'm not talking through my hat. For everything that I say, I provide evidence. Okay, so this is their second grievance, and this is the number and so on, and you can locate it. It's all on the record. This is what they say. All right. So West is superior, just trust it as well. Wikipedia does. Wikipedia says only West is trustworthy, non-West is not trustworthy. That is exactly the church preaching. Okay, so let's set aside Euclid, because there is no evidence and much counter evidence. And that's my book that we are talking about, which, by the way, has the subtitle, if you can see. This is, now it's become too big, is it? So how and why the church changed mathematics and Christianity across 2 religious wars. That's the subtitle. Book is here. If anybody wants to see, you can see. It's right here. And people just get caught up with the idea that Euclid was a black woman, not a white woman. What is the evidence if you don't have any evidence for Euclid? How do you give a portrait of him as a white man? This is racism. And there is a reason for it. We'll come back to that. So there is much counter evidence that there was no such person. So point is, we are told that, okay, now it is not only that there was no such person, but there is no axiomatic proof. This is important. Whosoever was Euclid, there's a book. What is there in the book? We are told that it is axiomatic proof, and that is why you should do axiomatic proof. But there is not a single axiomatic proof in the book. No Euclid, no axiomatic proof in the book. Now you are told that non-existent person had this intention to give axiomatic proof, which is not found. Now you believe that, you can believe anything. Intentions of a non-existent person. I mean, they don't believe intentions. And how do you know that it's not there? Because Hilbert rewrote after 700 years, the West ultimately had to admit. And Hilbert rewrote, the book is right here. You can just look at it. It's on Gutenberg. It's called The Foundations of Geometry. He provided the axiomatic proofs which are missing in the Euclid book. It's well known. This book was in 1899. And that gave the foundation for axiomatic mathematics. Okay. So Hilbert rewrote, Russell also wrote something on that, and so on. So this is what we have. Non-existent person had some intentions which are not reflected in the book, believe it. So it's not true, obviously. Now, why does a person they don't just tell you lies like this and stuff it in the school text? There has to be a motive, a very strong motive. What is that motive for that lie? We'll come back to that. So, okay, so the Euclid book actually never had those intentions, and there is plenty of historical evidence for that. And well, let me skip that. Point is, what is superior? The whole argument is West is superior, ape it. What is superior about axiomatic math? So, NCERT book tells a stream of lies, which is the typical church method. Don't tell one lie. One lie means you can catch the second, the third, fourth, fifth. By the time the person gets his mind can't figure out what is what. And nobody has the patience to chase 1,000 lies. So the strategy that you have to tell 1,000 lies to defend one is actually used. How do you fight those 1,000 lies? Think about it. All right. So stream of lies. So the first lie is that Greeks alone use reason. I showed that to you. This is false. I just showed you Nyaya Sutra 2. Uses Anuman. Anuman is deductive proof. You infer, but you infer from facts. You don't infer from axioms. But they use reason. So it's a lie. You should say that somewhere you use facts, you have reasoning based on facts, and you have reasoning not based on facts. So, well, Aryabhat deduced that the earth is round like a kadam flower and so on. I'll skip that. And he said that, Lalla, I explained that to you. This is in Shishyadhi Vriddhid. So this is the verse, and this is the translation. Far off trees cannot be seen. So it's very simple, and you can judge. You see where the ship goes over a horizon. If you see the distance at which it goes over the horizon, you can calculate the radius of the earth. And this is calculated. It is what is called ZAM in Indo-Arabic navigation. I won't go into all that. So it makes a misleading use of the word reason. You have two ways of using reason. One is scientific reasoning, where you use reason with facts. Science uses reason. It uses experiment, uses empirical facts. So that's reasoning with facts. But mathematics is religious reason, I call it. Reasoning minus facts. So two types of reason. Reason plus facts, reason minus facts. They never make it clear. So that they confuse people, think they're talking about reason. Greeks use reason. Which reason? I won't explain. They explain somewhere, it's stated somewhere. But I think this is a very serious matter, right? So let's discriminate between scientific reason, which is reason plus facts, and religious reason, which is reason minus facts, which is not used by Greeks, but which was used by the church. So did any of you know, by the way, let me ask, did you know this before, that there are these two types of reason being used? Just a casual question. Did you know that empirical is prohibited in math? Please, if you knew, please raise a hand. I would like to know. I would like to have some feedback. So you did not know, you knew? Okay, so you did not know. So this is how a whole lot of people are fooled. All right. So you wrongly assume that the word reason means just what you think it means, which is scientific reason plus fact. It is not. It's reason minus facts. So it fools children, it fools people. And this is class 9 mathematics. Can't just blame the NCERT. A nation of 1.4 billion people, no, we should be doing something about it. If nobody does anything, it's okay, वो तो NCERT का काम है, हमारा कुछ काम नहीं है. And it's your children or grandchildren. So you need to take care of them anyway. So the myth of superiority. Let's go back to the origin of this myth of superiority. It's based on series of falsehoods. So let's understand the origin of that myth. So right from the 4th century, when the church married the Roman state, the 4th century, Council of Nyssa, and after that, it captured the Roman state. And after that, it changed everything. It changed its dogmas. And it started asserting Christian supremacy, which went on for the next few centuries, which kept mutating. So this was based on its revised doctrine of the soul, which was against its earlier belief in equity. Come to that in the last part of the talk. So stream of lies. So by the 5th century, church was already using a secular argument from history, false history. Orosius wrote the first false history against pagans. Now, during the Crusades, this thing, it shot up, it became viral. It became a case that all knowledge from Arabic texts was attributed to early Greeks. So this is one of the books that I have, is Science Western in Origin. I have it here if somebody wants to see. This was just a simple, just a wild lie like that. No evidence. People like Euclid and so on. You have heard the stories of Archimedes. Do you know any evidence for Archimedes? For that matter, do you know any evidence for Pythagoras? Please tell me if somebody knows. You just hear the stories. And the stories are stuck into your mind from childhood. Don't think the church is only about Christianity. Church is about power. So the point is, they attributed those texts to early Christians because Eusebius said that the early Christians, early Greeks are the sole friends of Christians. Okay. Now that made the knowledge in these Arabic texts theologically correct, and those Arabic texts were translated and used in the first universities, Cambridge, Paris, and so on. All of them, they used these texts, were translated into Latin. And if you want to list, I won't, but they were all Christian universities. They were all set up by the church during the Crusades. Okay, so let us take, for example, Paris University. Now, who was the chancellor? The Pope appoints the chancellor, not even the vice chancellor. He appoints the chancellor with the bishop at the command and so on. And this is how the university ran. They're completely under the control of the church for centuries. And they are supposed to be the great universities. You think they are very great universities. What did they do for you? You just heard stories about their greatness. But this is the real fact, that this is from a primary source, by the way. Primary European source. This is an edict issued by who's the name? What's the name of the Pope? It is written there. I can't read it. Gregory. Yeah. So it is an edict issued by the Pope. It is available, and this is an original source based on that. I'm not just throwing something in the air. All right. So in the 14th and 15th century, we know what happened. That the doctrine of Christian supremacy was used to justify genocide. All the Native Americans were killed. And this was justified using doctrine, a papal bull called Bull Inter Cetera, that any piece of land belongs to the first Christian to cite it. Like, Vasco da Gama discovered India, Columbus discovered. The discovery there means is a Christian who saw it first, and therefore the land belongs. They used to read this out. And they can be enslaved. So I won't read all these bulls out, but there are links there. These are well-known things which ought to be well-known. So there is a right to enslave or kill non-Christians. That is what these bulls say. But after 2 centuries, there was a change. Because there was a huge business of slavery, and huge number of African slaves came to America, and then they converted. And when they converted, now the justification failed. How do you enslave them when they have converted to Christianity? So they invented a new justification. It was called the curse of Ham, the curse of Ham, which is the Bible defense of slavery. And this is a book which is, so please read these books, okay? And these are, this was published just before it's 1850, before the Civil War. All right. So this is the justification, and the justification comes from the Bible, and the idea is that white supremacy is a mutation of the doctrine of Christian supremacy. You can enslave blacks because God cursed them, and the color shows it's black. That's the curse of Ham, or called the curse of color. Now this again mutated because slavery, colonialism replaced slavery as the major source of wealth. So there was the Aryan race conjecture. You know what it was, that the Aryans came and the white Aryan, that's an important thing. The white Aryans came and they populated India. The black Dravidians pushed them out somewhere. That's what the story goes. Completely false. That's a different matter. But that's the story. Now, once that is the story, then what do? You can't say that we are superior because we are white. So you say we are superior because we are West. So white supremacy mutated to Western supremacy, which is what Macaulay states. And all of this, so it changed. All of this is just used. The same false history of science. All science was discovered first by Greeks, then by Christians. That was what they said in the Crusade. Then they said Greeks are white. All science was discovered by white. And then what did Macaulay say? All science was discovered by West. And you never checked it in 200 years. What are we doing? Okay, so these are continue to be used. I don't have written a lot of, I don't know, yeah. So this is a little summary that I want to give you of how Christian chauvinistic history evolved. First, it started with Orosius. Then you had the Byzantine model, where the Byzantines took things. Then you had the crusading model. Then you had the inquisitional model. Then you had the Christian discovery model. This is in a paper called Euclid Must Fall, which I presented at, where did I present? At Tübingen, and it is published in this Journal of Conversational Thinking. So please take a look at it. It's a very systematic falsification of history, which has been going on for centuries from 1500. Okay, so that's why we are, it's a detour. I think I should shift from that. So they are superior, you trust them, and that is what the NCERT says. Believe that. All right. So this claim is, of course, blatantly false. Why is it blatantly false? Because science needs mathematics. You can't do science without mathematics. And West was behind. West was behind for thousands of years. It was behind Indians, Egyptians. How could they do science? Right? And I want to say that almost all aspects of school mathematics today, arithmetic, algebra, trigonometry, calculus, probability, and statistics, are things which the West obtained from India. The only exception is geometry, which they have got from Egypt. So I'll come back to that. So let's start with arithmetic. Oh God. Where did I go? I missed the. Okay, I'm sorry. I just lost a. It's what happens. Okay, we finished with this detour. And we are arithmetic. That's where we are. I'm sorry. So we've well known that Europeans took arithmetic from us. They themselves abandoned their arithmetic as inferior. Roman arithmetic. They called it Arabic numerals, but we know that those Arabic numerals went from Al-Khwarizmi or Baghdad from India, who wrote Hisab al-Hind. All right. So that's why they are called algorithms or algorithms, because Al-Khwarizmi's Latinized name was algorithms. Well known. And when was this? We are talking about 10th century, 12th century, and so on. 15th century. The point I want to ask, which nobody mentions, is why did the Europeans abandon their native arithmetic? It was backward. Why did they abandon? What was the pressing need for them to abandon it? And we keep singing praises of zero, from here to Manoj Kumar. So it's a very nice song, but that's not the reason. It's not zero was a problem. It was not a solution. So it is not the answer to why. But it's a question which our historians have never asked. So point is, efficient Indian grid gave a comparative advantage in commerce. And Fibonacci, who was a Florentine trader, he traded with Africans, and there he met the Arabs, and that's where he got this idea of Hisab al-Hind, which he translated as Liber Abaci, and that's what he wrote in 1203. So the point is that let's take an example why they are inefficient. So number like 1788, you need 4-digit number, you need 12 symbols in Roman arithmetic. Absolutely inefficient. But that's just the beginning. If I want to, so the pebble arithmetic, backward pebble arithmetic of these Europeans, their largest number is a myriad. You know what a myriad is? Myriad is just 10,000. So I have the definition from Oxford English Dictionary here. It's 10,000 as a number. But its significance, it connotes infinity. It's also from the Oxford English Dictionary. So like all the myriad stars and countless myriads of man and so on. So it connotes infinity, because if you try to count up to a myriad, it is 10,000, that's a lot. So it was a very, very inefficient arithmetic. Compared to that, in the Yajurved, you have a parardh, which is a trillion. And in the Lalit Vistar, you have 10 raised to 53, which is Talakshan, and it goes on. Where myriad? Where 10 raised to 53? And they say, those guys wrote the Veda. How will they write it? They didn't even know the arithmetic. So that's the point is, it's just spinning stories. Any absurd story, and just go on spinning it, and people believe it without checking the evidence. So it is, this inferiority stretches back to antiquity. So the very names of small Greek numbers and Roman numbers are taken from Sanskrit. Let me turn it around. Just look at the number names. Everything is from Sanskrit, it's copied from Sanskrit. And it is clear that it is went from here to there because it follows the knowledge gradient. Those guys didn't have numbers beyond a myriad, right till recent times. So this is well known. The number in November is from Nava, which is ninth month. It was the 9th month at that time. So on. So we have the point is that it took them so many 2,000 years to understand. By the 13th century, they understood that just number names are not enough. They need the thing. They need the method. Now you see why it is so. Let's look at Roman arithmetic. If I want to do 89 plus 79, 2-digit numbers, it's not a very complicated problem, is it? Try to do it in Roman numerals. It's 18 operations. 18 operations. You do 18, 89 into 79. You have to do repeated addition 79 times. That is 1422 operations. Compared to just 10 operations which you do in algorithms. So it is vastly inefficient what they have. And this is discussed, that is what I discussed in this book, Aryan-Vedic Conjecture, that they could not have done, they could not have been, they did not have the math, they did not have the calendar, they did not have the, that's also part of the culture, very much part of the culture. So now the problem with zero, we know that it comes from cipher or cipher, which means a code, which means a mysterious code. And why is it mysterious? Because Roman numerals don't have trace value. They are pebbles, coins, counters. So XX, I is 10 plus 10 plus 1 plus 1. But 10 is not 1 plus 0 equal to 1. So they said it is mysterious. They are very suspicious. And as you know, Florence passed a law against zero. We still follow it, that if you write something in Roman numerals, you must write it in words. Because you can add a number of zeros at the end, and that can increase the value of a financial contract. And so this law originated at the time when Arabic numerals went to Hindu numerals, if you like. I don't like to call them Hindu numerals, call them Indian numerals, because Buddhists also used it, Jains also used it, and so on. So Roman arithmetic lacked fractions. Julian calendar has leap years, doesn't have a precise definition of tropical year in fractions, because they didn't have fractions. And so they could not say 365 and 1/4 they could actually manage after some time. But the Gregorian reform of 1582 had to say 3, 4, 1, 2, 4, 1. that every fourth year is a leap year, every 100th year is not a leap year, every 1000th year is a leap year. So they gave such a complex system. That is why people got confused in the year 2000 whether it's a leap year or not a leap year. They could not state it as a fraction. 2.241 they could not state. So the reformed calendar is still inferior because you use leap years. So you don't get equinox on the same date every year on the calendar. It's an inferior calendar, even they stole from us anyway. They still got it wrong. So Gregorian calendar did use inputs from India. So here is the original handwritten letter from, I got it from the Jesuit archives in the Vatican. And this is Matteo Ricci, who was a favorite student of Clavius, who performed the Gregorian calendar reform. He says he is looking for a honorable mood or an intelligent Brahmins to tell him about the Indian methods of timekeeping. This is original source in his own handwriting from 1580. Okay. So anyway, let's go on. Point is, they did not understand all the way. Right up to the 19th century. Augustus de Morgan, famous professor of mathematics in University College London, he didn't understand negative numbers because zero relates to negative numbers. So he said negative numbers are impossible. This is what he says. This is book. It's available on the archive. Look at it up. What does he say? 10 minus 20 plus 50 is impossible. Impossible. You agree? It's nonsense he is talking. He is the professor of University College London, famous professor. He's written so much, so influential. But 10 plus 50 minus 20 is okay. That's what he wants to say. 10 plus 50 minus 20 is all right. So this is in his textbook. And this chap, he goes on to say, see what he says. He did not understand ordering of numbers. This is very important because that's why the West did not understand calculus. You say minus 9 is less than 0. He refers to Indian source. Minus 9 is less than, he said, why can you, 0 is nothing? How can something be less than nothing? He's still thinking in terms of pebbles. 0 means no pebble. How can something be less than that? So he's thinking into his entire thinking is in pebble arithmetic. And this is, we are talking of 19th century, 1898. After Macaulay said we are so extremely superior. Anyway, so these are, there are, this is, I'm just coming to, he says that it is belief in witches is 1,000 times more possible. So algebra is from Algebra wal Muqabla of Al-Khwarizmi, which translates 7th century Brahmagupta's work on Avyakt Ganit of polynomials, so on. But the point is that algebra, you get surds. So square root of 2 is a surd. And surd means deaf. So why is square root of 2 deaf? We still use that terminology. So this is what surd means. This is again of Oxford English Dictionary. Means deaf. So why is square root of 2 deaf? So if you look at the Shulba Sutra, square root of 2 is the diagonal of the unit square. So it's a karna. So you say bad karna. Karna also means ear. Bad karna means bad ear means deaf. That is how square root of 2 is the diagonal of the unit square. If you take the diagonal of the unit square, that will be exactly equal to square root of 2, right? So that was mistranslated. Word sign, we use the word sign. What is the word sign? Sign comes from Arabic jab. Why jab? Because in India it was jiva. Jiva went into Arabic as jiba, and then the Toledo translators it didn't understand. The point is there's a conceptual error there. Conceptual error there because the moment you say sign, you are thinking the word trigonometry suggests that it's all about triangles. It's not about triangles. Okay, it's about the circle. So they made this mistake. But if I ask today this question in my pre-test paper, so I say about trigonometry, what is sine of 92 degrees? And students can't obviously find a triangle which has got right angle triangle which has got 92-degree angle. So they start wondering because it's nothing about triangles, it's about a circle. They don't teach them. Because you teach mathematics, you teach imitating the West, and all its stupid mistakes. You have the same terminology and so on. Okay, so I think I have given you a clear idea. In all these cases, arithmetic, algebra, trigonometry, various degrees of incomprehension by Europeans who, while copying from Indians. All right. And if you have decided to declare the class duffer as superior and we are playing follow the leader, then we are going to be hit that way. And that is what has happened. And probability and statistics is very much there in India. It is really there in the Rigved. This is the article of mine. 2-3 articles are there. Relates to the game of dice. And the first mention of the game of dice is in the Rigved, in the Aksha Sukta. So, Somasya Majab Tasya Maksho. That's what he's saying. So it is, it is so gripping, the game of dice. That's the idea. And point I'm making very quickly is that you have a concept of Mahabharata of an unfair game. There's a concept of unfair game. There's also a concept of a fair game or an unbiased game. And therefore, you have a concept of probability. Then one part, that's the story of Nal and Damayanti. You have Nal. Rituparna shows off his knowledge of mathematics. He's the king of Ayodhya, and they are both rushing for Damayanti's Swamvar. And he shows off. He says there are some number. He gets 1,000 something fruits in that tree. So Nal says, "Okay, wait, I'll count it. I'll cut down the tree. You go ahead." But he can't reach without Nal because Nal is the expert charioteer. So then they swap. He explains that how he did it. So it's not done by sampling. How do you count the fruits on a tree? How do you count the leaves on a tree? You do it by sampling. And then permutation, combination, binomials, and theorem, they're all part of Indian Ganit. That's there in that paper. I won't go into it. Key point I want to talk about is that probability theory is not understood in axiomatic math today. It's not understood. Why is it not understood? How do you explain what is probability? You take relative frequency. But relative frequency does not converge to probability except in a probabilistic sense. So the frequency interpretation fails. Subjectivist interpretation fails. You can't say it's a degree of belief. It applies to quantum mechanics. What's happening to the electron is not your belief. You're seeing the pattern. You're seeing a two-slit diffraction pattern. So it's a fact. It's an objective fact. The major theoretic axioms, which is how you teach, which is how I learned, are wrong. They fail because in quantum probabilities, you don't have a Boolean algebra. You're defining it on a logic, which is a quasi-truth function logic. It's not a Boolean algebra. Now that's a technical point. I'll skip it. Point I'm making is it's not understood to this day because they copied with incomprehension. And this is the statistics you're going to use for your chat GPT and so on. Let's come to calculus. So I said it originated in India. It was stolen by Jesuits in the 16th century. Why? Because calculus was used in India to derive precise trigonometric values. How precise? This precise. So these are 24 sign values. And as you can see, the precision is going to a very large number of decimal places. You can see the large number of zeros. So this was needed for the European navigational problem. Now, European navigational problem is the problem of determining latitude, longitude, blocks of rooms. Now, this is again a school text matter. I have a school text on that. It explains it. It is called Raju Ganit. And we don't teach our children. The idea is to teach them latitude, longitude, size of the earth. How do you determine all that? So this is the European navigational problem. And please take a look. This was the biggest scientific challenge facing Europe because their means of wealth was all overseas. All the money came from there, whether it's piracy or loot or whatever you did had to come from overseas. And if you don't have good navigation, everything goes into the sea. So it's a major challenge, acknowledged by all the governments. All the governments gave prizes. And solution of these three problems required precise trigonometric values. For example, loxodromes. I don't know whether you know what loxodromes are. Should I explain? So if you're sailing in the sea, these chaps were very primitive navigators. So they thought that if you go in one direction, you will go in a straight line. So one direction, go by direction of the compass, or you take a stellar rhumb line, 2 stars are there, they're joined by a straight line, keep following that line. And they said we must go in a straight line. But you don't go in a straight line. You go in a curve which is called a logarithmic spiral, unless you are going in the cardinal direction. It spirals towards the poles. So this was their first problem, lots of rooms and so on. I don't have a picture of that. So to solve that, you have the Mercator charge, which requires a table of seconds, requires a table of precise trigonometric value, which is, let me skip that. Your latitude, longitude, of course you need trigonometric values, and they were done in India like that. So there's a reading list. Let me skip that. The summary is basically this, that Newton and Leibniz did not discover the calculus, as our school text says. That is false history. And the discovery is a Christian discovery, like Vasco discovered India, Columbus discovered America, and so on. It is not real discovery. All right? It's just called discovery. The first Christian to come across that piece of knowledge becomes its owner. And this knowledge went from India. It was there for almost a century before Newton. Cavalieri had it, Galileo had it, Kepler talked about it, and so on. So I won't discuss all that. It is there in my, this is a very fact text on that. They have written this, mentioned this. No, I can't discuss all of it. It's very heavy. I can't even lift it. I'm becoming old. What to do? So, point is, what difference does it make in the story? We are talking about teaching. Maybe we did it first. Now, first thing you have to understand, why does anybody steal knowledge? Because he doesn't have enough of it, right? Should we ape what they did? I think not. So, unlike other cases, of arithmetic and algebra, West admitted its failure to understand. Hence, Dedekind, 250 years after Newton's death, he invented real numbers. But he used Cantorian set theory, so real numbers were only done with axiomatic set theory in the 20th century. So they admitted their failure to understand, and that is what has made calculus so difficult. Now let's understand what was their failure to understand and where is the religion in it. We have seen that it makes calculus very difficult. So let's understand the problem. They take the number square root of 2, surd. All right, what does it mean? That if I extract the square root by using Aryabhat's algorithm, the algorithm for square root extraction that you learned in school, the process will not terminate. Keep going on. You can't write down a number exactly which is square root of 2 such that if I square it, it will give me 2. Okay. So, it's not come out. Okay, never mind. Square root of 2 is 1.414, etc. So I can look upon it as an infinite sum. So it is 1 plus 0.4 and so on, which I can say as 1 plus 4 by 10 plus 1 by 100 and plus 4 by 1000. So it's an infinite series. Is that clear? This infinite series, it's an infinite sum. How do you do an infinite sum? Finite sum you know how to do. How do you do an infinite sum? And so that's the question of real numbers, that how do you do this? And same kind of problem will arise with pi. So this fact was known from earliest times in India. It was known to many others. So, for example, the name for square root of 2 in the Bodha and Shubha Sutra is Savishesh with an avshesh. So Savishesh, that's Bodha 2.12. Won't go into all those details further. Point is, you are summing a finite number of terms and saying this approximation is good enough for practical purposes. That's what you do in practice. That's what you still do in practice. I take a finite number of terms, I stop there and I say this is good enough. If I want more terms, I can get more terms. If I want more precision, but I never sum the entire infinite series. And same way, Aryabhat will give an asanna value of pi. Asanna means nearby value of pi. All right. So there was a pragmatic attitude that with an infinite series, simply sum a finite number of terms and to the required precision. And that's what we still do. But the Western attitude was different. Westerners wanted an exact sum of an infinite series. How do you do that? So that's where the religion comes in. Why do you want an exact sum? Why did the West want an exact sum? Because their view of mathematics was religious. And this view of mathematics is religious right from the time of Plato. So Plato, I'm giving you the original source, Meno. Now what you have to do is you have to search for soul. Okay, search once, twice, thrice, 4 times. So here we are. The soul then as being immortal and having been born again many times. We are talking about the soul. Plato's notion is very similar to the Hindu notion of Atman. Almost identical. So it has been born and it has learnt all these things in its past life. And therefore, can recall that past knowledge. How to recall it? Show it a figure, show it a diagram. And that's what Socrates does. He has an argument with the slave boy and he demonstrates the slave boy's knowledge of geometry, innate knowledge of geometry. He calls Menos slave boy and says, look, you didn't teach him. He doesn't know geometry. And see, he's giving wrong answers. But I'll show him this and he will on his own understand without my having to teach him. So he has an innate knowledge of geometry. And that innate knowledge comes from the fact he's a slave boy, but he has an equitable notion of soul. That's why he's using a slave boy as an example. So he has this notion of soul, which is tied to knowledge of mathematics. And that is why the word mathematics, that's the meaning of mathematics. Because he's talking about learning. And wait a minute, I should have shown you that portion. It is here. Yeah, let us this. So, Socrates, do you mean by saying that we do not learn and what we call learning is only a process of recollection? That's the Platonic doctrine. And so he shows that it is learning is mathesis and all learning is recollection. That's the Platonic doctrine. And therefore, the word mathematics comes from there. All right. So let me try to explain this some more. So Proclu explains that mathematics derives from mathesis. So can you read it? Is it clear or not? I can't make it much larger than that. Readable? Okay. So this then is what mathesis is, recollection of eternal ideas in the soul. And so on, because the soul knows about it. And so it's not a secular activity for him, mathematics. It's a key means of propagating his religion, which is why the church shut down these philosophers and smashed them. So he quotes again from Plato's Phaedo. Though not such learning, evidence of such learning can come from many areas. It is especially from mathematics that they come. And as Plato remarks, take a person to a diagram and you can show that most clearly that all learning is recollection. And Socrates uses the diagram. And you remember your school geometry, it had lots of diagrams. Nothing to do with axiomatic proof. It's about arousing the soul. That's the philosophy behind it. Okay. So this part of the soul has its essence in mathematical ideas. And it is only mathematics. So Pythagoreans said that everything that we call learning, so the doctrine obviously dates back from before Plato, an Egyptian doctrine. Oh, that is why Socrates used this. No, I think I have put the wrong comment here. It basically says that geometry, let me see if it is there in the next slide. Yeah. Well, no, it's not there. Basically, it says that geometry has its root in eternal ideas. It was an important slide. How did I muck it up? Geometry has its root in eternal ideas, and therefore it is that mathematics works as a means of arousing the soul, because like arouses like. sympathetic magic. Soul is eternal. This has eternal truths, and therefore it arouses. And anyway, what Plato says that, he says this, learning eternal truth. So it is not of aught perishable or transient. Geometry will draw the soul because knowledge of geometry aims for knowledge of the eternal. That's what Plato says in his Republic. Now we are a republic, we should read what states. So geometry has eternal ideas. So that was the idea. That was the philosophy, that was the religious belief, and that was the religious belief which was suppressed by the church very brutally in its first religious war with the pagans. So point is that they believe that mathematics contains eternal truths and therefore it must be exact. You can't have something which is anitya. Like in the Apastams Shubha Sutra, it will say square root of 2, it will say anitya, sa anitya. So you can't have something which is inexact, must be exact. That's the point. And whether it works for all practical applications or not, Plato is very explicit. It's not being done for practical applications, it's being done for the soul, for the good of the soul. Because arousing the soul makes a person virtuous. That's his theory of the Republic. So it is very clearly connected to religious beliefs right from the time of Plato. It is very much there. These texts are all publicly available. You just have to read it. Well, as I said, we already talked about diagrams. So diagrams have no connection to mathematical proof. Russell says that. Why do you find diagrams there? Okay. So there are no, it's a falsehood that Euclid gave axiomatic proofs. So what he says very clearly is that demonstration, well, proofs should retain their demonstrative prose even when no figure is drawn. That is not the case. In fact, the figure leads to what are called errors because proposition 1 and 4 are based on figures, they're based on empirical observation of figures, that you have two arcs that are intersecting, you observe them to intersect, but they may not intersect because they may not be continuous, they may be like arcs on a computer screen, it's pixelated, they may go through each other. Okay, so point is that Russell subscribed to the Cambridge superstition that the non-existent Euclid intended axiomatic proofs because Cambridge University kept asserting that. Let me skip that. Let's go back to the church and its notion of soul. See, Plato used a pagan notion of soul, very similar as I said, but this was cursed by the state church. So I have another book on that. Sorry, I'm showing so many books. So it's in the second chapter of this book, 11 Pictures of Time, the curse on cyclic time. So the church cursed it. Now, cursed this notion of soul because it was equitable. Okay, and how was this equity explained? It was explained, for example, by saying that souls are like spheres, geometrically. One sphere is like another. And if you look at Justinian's fifth anathema, he pronounced as head of the church, he pronounced this curse. And those drawings of Justinian and Theodora are all there in Istanbul. If you go to Hagia Sophia, they're all there on the ceiling. Now I don't know what is happening. It's turned into a mosque. So, but they're all there. At least they were there when I went and saw it. So he cursed this notion that all souls are spheres. If anybody says or thinks that at the resurrection human bodies will rise spherical in form, let him be anathema. Anathema is a big curse. So that is where the religion comes in. And of course, there's the whole issue of equality. Every theorem of Euclid's elements, so-called the book, is about equality. The word was changed to congruence by Hilbert. Because equality doesn't fit into his idea of axiomatic proof, and so on. So we ape it. Today we teach only congruence. If your children are studying in school, you open the text, they only talk of congruence, never about equality. It is political equality. All right, so let's come to now what the church did. That got this book, Euclid, and It imputed to it axiomatic proof. It said that this book has got reasoning minus facts. It said it has got axiomatic proofs. They are not there. It said it's not our invention by the church, because the church has some reason to reason without facts. And they wanted to compete with the Muslim Akli Kalam. And they failed to convert the Muslims by force the way pagans were converted, to set some military failures. I mean, beyond Spain, for centuries they were military failures, except for the First Crusade. So they had to convert by other means, and they could not convert by force, they could not convert by reason, they could not convert by Bible, because the Muslims rejected the Bible as corrupted, like Isaac Newton did. So the church did use it. Axiomatic proofs are not there in Euclid, but they are there in church theology. So Aquinas, who was the leader of rational theology, he uses his angel theorems. Many angels can fit on a pin. Now that's the cartoon, but let's show you the Summa Theologica also. That's the original source. I'm going on the internet. How many angels can fit on the same place? So because they'll tell you, oh no, this is all false, and they did not prove anything. It's right there in Summa Theologica about fitting angels into a head of a pin. Right? This is all right. So point is, he had to reason about angels. There are no facts about angels, so he made an axiom, and then he reasoned and he got a conclusion. A very convenient way of reasoning for the church, and we are following that. So it has no practical value, but it has superior political value for the West, because they lay down the axioms and so on, and they control mathematical knowledge the way church controlled its rational theology. And well, it makes the simplest things very complicated. Now that's an advantage, making things atrociously atrociously difficult. Because what do? You don't understand, so you say, I must ask somebody. Whom will you ask? You are taught, trust the West, mistrust the non-West. Simple principle. That's what has been taught to you. You go to Wikipedia, that follows the same principle. You Google, and now once you have that control of mathematical knowledge, then you can claim that science, like Stephen Hawking did, or his that rascal of his, the rascal co-author of his in Cape Town, J.F.R. Ellis, that science has proved the truth of Christianity, and we will not let you talk. I wanted to talk in Cape Town math department. He refused to let me talk. He started an agitation, planted all sorts of news in the fake news in the papers, and so on. So the point is that control of mathematical knowledge can be used to control science. Your religious beliefs can be pushed into science, as Hawking has done, and as Tipler has done, as Penrose has done. Got the Nobel Prize 2 years ago. I have a long article on that. Won't go into all that. Let's stop at this point. So just the conclusions. We made a strategic blunder by not studying the enemy, the colonial enemy, and his nexus with the church. And we refuse to check it even today. They must trust the West. That's what NCERT says. That's its official policy in official documents. And then our children grow up as mental slaves. And Macaulay argued that colonial education was needed for science. Therefore, decolonization must begin from Ganit, math, central thing. And from a critical examination, re-examination of its related history and philosophy, particularly the philosophy. It's not just about history. Everybody is doing something about history, but nobody is touching the philosophy, which is most important, because when you teach, the philosophy is what is going to. Thank you very much. I'm sorry I don't have lost track of time.
I think, thank you very much. It has been a fantastic journey through mathematics, philosophy, history, and all the civilizational detours that you took. But it makes a very important point of one, that we must understand what we are learning, and there is a whole agenda behind it. I think we have never seen it, even those who have studied this. We have never seen it from that point. So it's absolutely a fresh way of looking at it. But you also, early in the talk, said that where do we go from here? I think that's very important. Where do we go from here? You are making this effort to teach calculus in a new way, etc., and also trying to establish the importance of Ganita. But Ganit also should have a philosophy. You know, I think that's the point.
Zeroism and so on.
Yeah, yeah.
Inexactly.
Yeah, yeah.
Inexactly.
So this is absolutely new. I don't think this is, as you said, I mean, 10 lakh rupees for proving 1 plus 1 equal to 2 in real numbers could be a nice way of doing it. But I think there should be a prize for asking people to write a thesis on these subjects and so on. So I think it's a very fresh look at ourselves. And I think apart from the fact that where do we go from here, one question that comes is, with all this that you just said, the Western science and etc. has reached a certain level. Can the Indian Bharatiya Ganit catch up with it, or for that matter, any other Ganit? So where do we go? Because we are really running against, racing against time.
I don't think so. Because I think that these points about science I have made already. For example, if you're talking about Newton's laws of motion, why do we talk of laws? That's a Christian superstition, the laws of God. Why do we want to have only differential equations? The problem is that if we talk of doing it differently, there is no way to persuade anybody because most people don't understand. One side, that's the church trap, that large number of people are ignorant. The experts are not with you. Experts are sold out. So how do you do that? For example, how do you now, you come up with something new, how do you push it? Because there is no support from anywhere. That's the challenge. That the ordinary people you can't go to, experts you can't go to. Now what do you do under those circumstances? No, that's the difficulty.
Also, I think, you see, in the defense of NCRT, I will only say ignorance. This kind of a knowledge, the person who wrote, he was writing for class 9th book. Some mathematics teacher.
It is Jayant Narlikar. It's Jayant Narlikar who's sitting there refusing to talk. It's Parveen Sinclair, who's a mathematics PhD, who was the director, refusing to talk, refusing to discuss it. So,
but I saw that you were part of that group in last book, I think this book that you showed last time.
Yeah.
Jan Nadikar is a part of that study.
As part of that, I wrote against him. I have written against his theories. He doesn't like me. I've exploded his theories. So what can I do? My first paper was against his theory.
Jan Nadikar's credit, he himself was a kind of a rebel in terms of steady state theory.
That is what Hoyle did. That is what Hoyle did. And Hoyle directly told me, and I asked him, that I did it because this, you have this Christian stuff getting into the Big Bang theory of creationism and so on. And therefore, he took the continuous creation route, which was what Al-Ghazali says. But it is not the same thing. So the theory of creating one hydrogen atom is rather absurd. I believe in continuous creation, but continuous creation of a different sort. Buddhism has continuous creation. We talked of conditioned co-origination. It has that sort of thing. So you can do that, but it has to be done differently and not in this way of science fiction. It's adopted. So
let me open it up for any questions or any comments.
Yes, please. Yes.
Yes, I'm Anup Bose. I'm a senior advocate in the Supreme Court, and I've been advisor to many corporates like the Tatas and Reliance.